So I'm going to revisit example number 3, that's the vomiting one. And I'm going to write it down using symbols. I want to figure out what the symbols are. So just to reiterate, we're going to say that event A is that he sees Wendy, and that event B is that he vomits. So what we want, so the first question, so we have, let's go through some of the numbers here. A 35% probability that Stan will see Wendy. So the symbol for that would be the probability of seeing Wendy is 35%. If he sees Wendy, there's a 70% probability he will vomit. So the probability of vomiting, given that he sees Wendy, is going to be 70%. If he does not see Wendy, the probability of vomiting is 20%. The probability of vomiting, given that he does not see Wendy, is 20%. So those were the givens in the problem. Those were the givens. And what the question was asking for, it was saying, what is the probability that Stan sees Wendy and vomits? So A was saying, what is the probability that he sees Wendy and vomits? And B was saying, what's the probability that Stan vomits? And that one was asking for the probability of B. So, well, doing all of that, looking at it this way, these are dependent events. His probability of vomiting depends on whether he sees Wendy. And we know that the formula for dependent events is that the probability of A and B is the probability, let's get that formula out. The probability of A and B is the probability of A times the probability of B given A, which is going to be 35 times 0.7, which I think we already did that, right? Times 0.7, which is 24.5%. Now the probability of B is not as trivial. B could be done in two different ways, right? So the probability of B so we could do it there or there. So the probability of, there's two ways to get B. We could do A, we want to know if there's the probability of A and B, and there's also the probability of not A and B. Now the probability of A and B, so what we want is it's going to be the probability of A times the probability of B given A. This one is going to be the probability of not A times the probability of B given not A. Now we're just going to add those together. And if we do that, we would get, well, this is our 24.5%. Not A was 65 times 0.2, which was the 13%. And you add them together, and we get the same answer we got before, which was 37.5%.